Hello, it's Mrs. Scarpel, and in this video we're going to take a look at what it means to be a function. And before we do that, we're also going to take a look at what does it mean to evaluate, because evaluate means something different from solving. So to evaluate means to find the value of an expression for a given value of the variable. So if I know what the value of a variable is, like we have here in example A, I'm told x equals 3, and I have an expression like 4x minus 5. Because I know that x equals 3, I can take the 3 and substitute it for the x in my expression. So we're going to have 4 times 3 subtract 5. 4 times 3 is 12, subtract 5, and we have the value 7 when we evaluate that expression. When we take a look at example B, I know that x equals negative 8, so we're going to take this negative 8, we're going to substitute it for the x, so we're going to have negative 2 times negative 8 plus 9. So we have negative 2 times negative 8. Pay attention to these signs. Negative times negative becomes a positive. 2 times 8 is 16 plus 9. 16 plus 9 is 25. So when we're evaluating an expression, we are replacing a variable in the expression with what that variable equals. To define relations, relations are when we have inputs with outputs. And we've had some examples where we had some descriptions with inputs and outputs. The inputs are going to be your x values, and your outputs are generally going to be your y values. So when given as an ordered pair, the x coordinate is the input and the y coordinate is the output. And if you think about the equations in the form y equals mx plus b, if we were to replace the x whenever we have a slope and a y-intercept, if we replace the x, if we put in for the x, we will get the y value, that output. And that's why we can say that the x is the input and the y is the output. Now, a function is a relation that pairs each input with exactly one output. So if I plug in a value for x, there's only going to be one value of y that comes out. So a function is a relation that pairs each input with exactly one output. That's key, exactly one. What that also means is when we start looking at mapping diagrams like I have here on the left, or in tables, I don't want to see inputs repeated. Because if I have an input repeated, that means it's being mapped or paired with more than one output. So if we take a look at this mapping diagram, I have all of my inputs in this oval, and I have my outputs in the oval next to it. And these arrows from the blue numbers to the red numbers are mapping. So like the number 2 here, this input is going to negative 4 and it is going to negative 6, while 3 is only going to negative 6 and 4 is going to negative 8. But because 2 is going to 2 numbers, we have an input that's going to 2 outputs. This is not a function because we have an input going to 2 outputs. or we could say in this case, is mapped to two outputs. If we look at the table, if I look at my inputs, I have 0, I have 2, I have 4, I have 6, I have 8, I have 10. I don't have any repeated inputs. Because I don't have any repeated inputs, I can say this is a function because there are no repeated inputs. Each input value has exactly one output value. We can do the same when they're in ordered pairs. If I look at my list, the x values are all the first numbers. So I'm just going to go ahead and circle all of my x values. I have -3, I have -2, I have -1, I have 0, and I have 1. I don't see any inputs that are repeated. So this is a function. Because each x value is paired with exactly one y value. If we take a look at example D and I do the same thing, we have 1, we have 2, we have 3, we have 1, we have 4. I have 2 inputs that are repeated. That input is the same value. So the input 1 is paired with 2 outputs. So this is not a function. Because one input is paired with 2 outputs. So you don't want to have any of your x values repeat like we have here in example D. We can also determine if a function is if a graph is a function using what's called the vertical line test. So a graph represents a function when no vertical line passes through more than one point on the graph. So here we have this dashed vertical line. I am just going to go ahead and make my own vertical line. I'm just going to draw it right over that. And I am going to move my vertical line, if I can get a hold of it here. There we go. If I slide my vertical line to illustrate what that dashed line could do, no matter where I move it, my vertical line is only ever going to hit one point. That makes it a function. Now keep in mind, a vertical line has the equation x equals. So all of the inputs on a vertical line are the same. So when you do the vertical line test, like when I go over here and it says it's not a function, that vertical line is representing the same x input anywhere on that line. So when we take a look at where the dashed line is going, they're saying it's not a function. It's touching my graph at 2 points. So for this particular x value, it's being paired with 2 different y values. So these 2 points are going to have the same x value, but they're going to have different y values. That means we have the same input paired with 2 different outputs. That makes it not a function. So you could always take a ruler, a pencil, something that you can hold vertically, and just slide it back and forth. And if you ever hit more than 1 point, and as I move along here, I'm not ever touching more than 1 point on this graph for example A. So this would not, or this would be a function, excuse me, this is a function because it passes the vertical line test. Now if I do that same thing with the circle, and I maneuver that vertical line through my circle, you can see there's numerous places where that line is touching the circle at 2 places. So because that line is touching the circle at 2 places, even just right there, this is not a function. Because it does not pass the vertical line test. So for a relation, which is just a pairing of numbers, to be a function, each input has to have, or can only be paired with, exactly 1 output. That's the key to any function. Each input, each x value, can only be paired with 1 y value.